guys, good evening. It's a weekend time, but I'm shooting your derivatives of sin x, cosine x, e to the x, and natural log of x. I want to point out to you that this is in section 2.7 on AP Classroom. These three videos on AP Classroom are done by a woman named Verge Cornelius. She is awesome. She heads questions on the AP exam, and she was the person that ran one of the videos during COVID in the spring. So she, the videos for them. So she's awesome. And the videos that she does in these three videos are going to be the same kind of things that I do in this video with different examples. So if you feel like you need to see different examples, go to those videos and watch them. The first outcome of today is to be able to fill out this chart. Now, I'm going to use the sketching a derivative method to show you how we can generate these derivatives. It's up to you whether you want to put those in your notes, but you definitely want to put the chart in your notes, okay? So let's look at this first one. This is the graph of y equals sine x. And you'll notice that the scale is pi over 2 and pi over 2. So it's not quite pi over 2 in one scale that you're used to, but we're going to go ahead and sketch the derivative. Now remember, when we sketch the derivative, what we do is we come to an x value on this curve, say 0, and then we figure out what its slope is. So it looks like the slope there is 1. And then that's going to be the coordinate on our derivative graph. So the slope value from our original graph becomes the y value on our derivative graph. So let's graph the point 0, 1. And like I said, this is pi over 2, 3.14 over 2. So 1 is going to kind of be like around here somewhere. Okay. Let's go to this next one. At pi over 2, the slope is going to be 0. And you might notice that's also the same case at 3 pi over 2. And that's also the case right here where we're kind of like coming around. It's cut off. So it says 5 pi over 2. So I'm going to put that over here. And it's cut off over there. But, you know, you get the idea. So I'm going to graph 0 at pi over 2 and at 3 pi over 2. And where it's cut off over here, 5 pi over 2. Okay, and then let's look at this one right here. We have a, right here at pi, it looks like the slope is -1. And the slope at 2 pi, it looks like it's +1. Okay, so let's graph. And again, like I said, the scale over here is pi over 2. So 1 is kind of, where it says pi, we're going to go -1. And then 2 pi, we're going to go +1. And now let's connect these dots. Oh my goodness gracious. Do you notice what this graph looks like, ladies and gentlemen? If I come back over here. If you said, hey, isn't that the cosine graph? You're absolutely right. So y prime, or the derivative of sine, is cosine. So there we go. The derivative of sine is cosine. So that's the first graph. Let's go to the second one. Let's see if it comes up kind of the same. This is the graph of cosine. And we're going to do the same thing. We're going to make a t-table. And in that t-table, we're going to have x and y prime. So we're going to pick an x value. This is 0. And we say, what's the slope at that point? And that's also 0. Okay, and we can also see that the slope is 0 at pi, so I'm just going to write that next to it. And we can see that the slope is 0 at 2 pi. I'm going to write that next to it. So let's graph those points. 0, 0, pi 0, and 2 pi 0. Okay, let's go to this next group. Let's get what that guy is. At 3 pi over 2, it looks like the slope is 1. And it happens to look like the slope is 1 over there. So we're going to graph 1 here. And we're going to do the same thing at 3 pi over 2 right here. Okay. And then what about at pi over 2, and which was 5 pi over 2? Pi over 2 and 5 pi over 2, they both have the same slope, which it looks like it's -1. So let's graph those, 5 pi over 2 and -1. Let's connect these dots. Oh my goodness gracious. Are you noticing that this is also a trig function? And are you noticing instead of going up and then down and then up again, it went down and then up and then down again? If you notice that this is the graph of sine x reflected over the x-axis, so negative sine x, you are correct. So we're going to come over here and we're going to say f prime is negative sine x. So we have 2 down, 2 to go. All right, so let's go here. All right, here is the graph. This is the original graph of y equals e to the x. We're going to do the exact same thing. We're going to pick an x value. We're going to figure out what its slope is, and then we're going to graph the value of the slope as the y value on the derivative graph. So this is the value -4 over here, and it kind of looks like the slope is 0, doesn't it? So let's graph -4, 0. All right. At -3, it's kind of, I don't know. I mean, it's not much more than 0. But remember, this is like, notice the scale now is going 0 to 1. So this is 0.5. So this is like up, I don't know what this is. Maybe point 0.1? Who knows? It's a kind of a, it's a very shallow slope. We can see there. Okay. And then we notice that at -2, it's still a very shallow slope, but maybe a little bit more. So let's say that that's like 0.5 or something like that. Okay, so we'll graph that around there. Okay, and then let's find a slope that's a little bit easier to maybe kind of estimate. I think right there at x equals 0, I think the slope is 1. So let's go ahead and make the slope 1 there. And let's come over here and go, okay, what's the slope at 1? So what's the slope here at 1? And it's kind of like the slope at 1, if you notice, it's kind of like up 3 and over 1. So let's say the slope is 3. We're just guesstimating right now. We're just trying to sketch it out. So we're going to go to 1, 3, and let's graph this. And oh my goodness gracious, am I just graphing the same graph? Does it just look like I'm graphing the same graph? That's because it is the same graph, basically. So the derivative of e to the x is e to the x. How about that? We always like to joke that the derivative of e, or the function e, is always depressed, because all his friends, when they get the derivative, they change, and e to the x just stays the same. It just feels so boring. You know, everybody else is changing. It's not changing. Ugh, tough life, tough life. All right. This is the function natural log of x. We're going to do the same thing again. We're going to make a t-table. We're going to make the x values and the value of this slope, and then we're going to graph the slope as the y value in the previous graph. Again, we're just trying to guesstimate here as best we can. So let's look at this. This slope right here, I'm going to come to this guy right here. So notice it's going by ones. I'm going to go to 0.5 right here, and I'm going to go, all right, what's the slope right there? I don't know. It looks like at 0.5, the slope is like 2, and maybe it's going up 2 and over 1, something like that. So we'll go to 0.5 and we'll go to 2. And then maybe we'll try at 1. Maybe let's try at 1. So I'm going to erase this and I'm going to try at 1. At the graph of 1, whoops, let me turn the pen on. At the graph of 1, we have the slope 1. Okay, let's go with that. So at x equals 1, we have 1. Let's come over here. Let's go to x equals 3. Let's draw ourselves a tangent line. Oops, little tangent line. It's like up 1 and over 3, up 1 and over 3, something like that. So at 3, we have the graph 1/3. Okay, so we have the slope 1/3 rather. So I'm going to graph that. And then at x equals 4, well, you notice that as we're going to the right, it seems to be getting flatter almost. So it's like, okay, well, maybe this is up 4 over 1. So maybe instead of 1/3, it's 1/4. And like, what are you noticing? This graph is doing this. So do you remember what this graph is, by the way? When we were doing our beautiful dance moves, if you were thinking, well, it kind of looks like half of Haya, you are correct. The reciprocal move, 1 over x, Haya, it is this branch of it. It is the x greater than 0 branch. So there you go. Your y prime graph is 1 over x. So going back to this original function right here, we are literally going to copy this chart in our notebook. This is kind of what we have to memorize. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of e to the x is itself, e to the x. And the derivative of the natural log of x is 1 over x. So that's outcome number 1. Are you going to have time to generate all those graphs to figure it out all the time? No. It's a way to get yourself out of it. If you remember your parent function graphs, you can kind of graph the slopes. But memorization or having this handy is going to be your best bet. Now, the second outcome of the day is to be able to use this in conjunction with the definition of the derivative. Now, why do we bring that back up? Well, we have these crazy notations here that both meant take the derivative. And then we learned power rule And we were like, well, then we found an easier method. But what if you can't use power rule? What if you're stuck? So that's what we got to see. Like, for example, you see this particular function and you go, all right, well, this means take the derivative, and then you plug in h equals 0 and you get sine pi minus sine pi 0, and you plug in 0 and you get 0 over 0. And you've been told try something else, factor, conjugate method, distribute, whatever. But you're stuck here. There's no way to factor. There's no way to conjugate here. So the real key here is to recognize that this looks exactly like the definition of the derivative, doesn't it? Okay, so your question is now, well, the definition of the derivative was basically the instructions would say, find f prime x at x equals blank when f of x equals blank. Those were the instructions. And then you would go, all right, I plug it in at 2, and then 2 plus h, and then you would plug it into the function. So let's see what this looks like. What is the a value, or the x value in this case? That would be pi. So my instructions are now find f prime x at x equals pi. And what's the function that I plugged in pi and pi plus h into? I plugged it into the function f of x. So this is my function right there. So I am basically saying to you, find f prime of x at x equals pi when f of x equals sine x. Well, you go to your chart and you say to yourself, okay, what's the derivative of sine? It is cosine. And then you do the problem. So f prime x equals cosine of x. F prime of pi equals cosine of pi. You think about your unit circle. You think about pi. Yummy. You think about the coordinates. You think cosine is asking you for the x value. So the answer to this problem is -1. Okay, so notice how I needed to know my derivative of sine, and I also needed to know what the definition of the derivative is, because I didn't have a way to get out of this problem otherwise. I had to know the definition of the derivative. Okay, let's look at the second one. Same thing. If I plug in h of 0, which is, remember, when we talk about substitution, we always try direct substitution first. So I would get ln2 minus ln2 all over 0. I would get 0 over 0. Okay, so that doesn't help me, right? That doesn't help me do what I needed to do. So the thing that I need to do now is I got to recognize, oh, this is the definition of the derivative. I have my values, and I can plug this in and I get my values. So what is the function? It's saying find f prime of x when x equals, well, what does x equal? What is this value right here? It's 2. And what is the function? The function here is, what did I plug 2 and 2 plus h2? I plugged it into natural log. So what's the derivative of natural log? It's 1 over x. And if I plug in 2 into that, what do I get? 1/2. Aha. So recognizing the definition of the derivative, and then being able to plug in my value. So that's why we need to know that, because there's no other way to do this type of problem. Can't use power rule, can't use foiling, can't use conjugate method. You got to use this one. All right. There's no h's here. And yet I'm stuck. I don't quite know what I'm supposed to do. Oh, right. There's the alternate method for the derivative. The limit as x approaches a of f of x minus f of a all over x minus a, which also means find f prime x when x equals something and f of x equals something. Okay, well, what is the number that I plugged in? Pi over 2. And what's the function that it's getting plugged into? Cosine x. So let's go back to the front screen. What is the derivative of cosine x? It is negative sine x. So we go, all right, I know now what the derivative is. Let's come back here. F prime x is negative sine x. Let's plug in pi over 2. We get negative sine pi over 2. We think about our unit circle. Pi over 2 is at the top. The coordinates are 0 and 1. You want the y value because it's sine, so -1. There we go. We did our problem. That was the alternate method of the derivative, using the derivative of cosine. So remember, we had two outcomes today. Number one, being able to find the derivative of sine x, cosine x, e to the x, and ln x. And number two, being able to find the derivative using the definition of the derivative and alternate definition of the derivative. All right, this is kind of just a curveball thrown in the middle of this puzzle. Or game or pitch. I don't know what analogy I was trying to use there. All right. So it's saying find the derivative of, wait a second, there's no numbers plugged in. So it's just basically saying find f prime x. Okay. So find f prime x. It didn't have any number plugged in because x is just there. So when f of x equals what? What do you think the function is? Well, what am I doing? I'm raising x to the 10th. I'm raising x plus h to the 10th. So the function was x to the 10th power. So I'm asking you, what's the derivative of that? And that's power rule, 10x to the 9th, and I'm done. So that was just kind of a random problem in there. Verge also does that in her AP classroom videos. I thought I might emulate that for you here. Just another way of seeing the definition of the derivative. Let's look at this guy. Okay, let's think of what this is again. The limit as h approaches 0 of f of x plus h, or a plus h. I can put a right there all over that. Okay, so find f prime x when x equals what up, and f of x equals something. Okay, so what is the number that's being added to h? This guy right here. So this is 5. And what's happening to 5 and 5 plus h? What function does it look like it got plugged into? It looked like it got plugged into e to the x. So we're going to plug this into e to the x. The derivative of that, sorry about that little phone alarm, f prime x equals e to the x, because e to the x doesn't change, poor guy, and e to the 5th it is. There you go. You can't do this problem any other way, can you? You can't factor it, you can't FOIL it, you can't conjugate it, you can't do just like trial and error. You got to know your definition of the derivative. Let's look at another one. Wait, why did you throw this problem in here? I don't know. Why did I throw this problem in here? Who knows? Because you were just like, I'm just going to factor that sucker. I'm just going to go x plus 2, x minus 2, and x minus 2. And I'm going to go kaboosh, kaboosh, as you know I like to say, and I get 4. Fantastic. So why was this problem thrown in the middle of this video? Because we like to show you when a problem can be solved multiple ways. Because, for example, this is also written in alternate method of the derivative form. Remember, I'm sorry, let me just erase this real quick. The alternate definition of the derivative says f of x minus f of a all over x minus a. So this is find f prime of x when x equals something and f of x equals something. Okay, so what is x equal? Well, it's whatever that guy is, or whatever that guy is, or whatever that guy is. So in this case, it's 2. All right, and what is the function that I'm plugging in? What is f of x? It's x squared. So what's the derivative of x squared using power rule? It's 2x. And if I plug in 2 into that, what do I get? 2 times 2 equals 4. Me personally, I think factoring was easier for that one. But alternate method of the derivative also works. So we've seen problems in this set where the alternate method was the only way it worked. In this case, you can choose. So it's good to be flexible and know multiple ways. That way, when there's multiple ways to solve a problem, you can do it. But if there's one way to solve a problem, you haven't put all your chips in factoring. Okay, let's do one more like that, and then we'll be done our video. So here's our video. The first time you ever saw this, you used the conjugate method. So I'm going to use the conjugate method here. And I'm going to go boom, 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 boom. I'm going to go limit x approaches 4. I'm going to multiply my roots. The whole reason we use a conjugate is that when we do the center terms, they cancel out. And then I get x minus 4 on the top. On the bottom, I get x minus 4 times the square root of x plus 2. Kapoosh, kapoosh. Plug in the 4. And I'm going to get 1 over root 4 plus 2, which is going to give me 1/4. Okay, fantastic. Conjugate method works. Well, guess what? What if I wanted to recognize that this was written in alternate method of the derivative form? Okay, so let's see. I go, all right, well, the alternate method or alternate definition of the derivative is basically telling me find f of f prime x when x equals something and f of x equals something. Okay, so what was the a value here? What was the value that was being plugged in? It's always this number right here. So the answer was 4. Okay, and then the second question that you're being asked is, what is the function? Well, it's pretty clear that if this says f of x, then this is the f of x right there. So we get the square root of x. So remember, when we do power rule, you're not supposed to have radicals, so you have to change it to a raise over root scenario. Then you can do the derivative using power rule, 1/2 x to the negative 1/2, and then you can plug in 4. And remember, as we talked in the first week of school, and we've reviewed a couple times since then, when we have a fraction exponent, the bottom number means root, the top number means raise, and if you see a negative symbol right there, that means to reciprocate. So let's do that. Let's do 4. The square root of 4 is 2. 2 to the first is 2. Reciprocal is 1/2. So I get 1/2 times 1/2, which is 1/4. I don't know. I think that one's a toss-up. I think maybe the conjugate method was easier. Maybe you found the definition of the derivative was easier. I don't know. But again, 2 different ways to solve that problem. You could use either way. It's not right or wrong to use one or the other. But if I have a problem that's a little bit more like a cosine or an e to the x, if I went back to the previous slide, where's my mouse? I've lost my mouse, people. I don't know where it is. It would probably be helpful if I held the pen right side up. Okay, so in this case, where you can only use the definition of the derivative, or this case where you can only use the definition of the derivative unless you want to sit here all of class and do x plus 10 to the 10th power, or this particular example where it's the alternate method of the derivative, these are all examples of how to do the same problem. So hopefully you get those down in your notes. You'll be able to do your practice problems tomorrow. Make sure you get those down, and you guys have a happy, happy day as usual. I hope everything's going well with you. Oh, doesn't want to turn off. Oh.